All right, and we're looking at module 5 now, which is going to go over bivariate data. So bivariate data, that means we have how many variables? Two. Thank you, Kim. Yay, Benny, everybody. Okay, two. Very good. So let's go to share screen. Let me make sure you can see my screen. Can you guys see it? This is our text for bivariate data on our Canvas site. So what we're going to use to show bivariate data is a scatter plot when it's numerical data. Remember, contingency tables are good for categorical data, but we're going to look for three things. Remember, with histograms, we looked for shape, center, spread. With scatter plots, we're going to look for these three things here. We're going to look for shape, trend, and strength to describe the relationships because we're looking at two different data sets. So what shape do they make together? What trend do they have together? And that trend is either going to be positive, meaning as one gets bigger, does the other get bigger? Or as one gets bigger, does the other get smaller? That would be a negative trend. If they move together, it's a positive trend. And then the strength, how close, is that trend and that shape to what we're seeing in the relationship. So we're going to write clear descriptions, interpret associations, and how to create the time series plot and the intensity maps are kind of, I have them as extra. The scatter plot will be on the exam. I think time series plots and intensity maps are very cool. You see a lot of them in the real world. But the scatter plot is going to be more useful to us as in terms of bivariate data. So what you're looking at on the right over here is, I don't know why, the married ages is down there. So what you're looking at here is a graph with two variables. And as usual, one variable is along the x-axis, and it looks like that variable is temperature. The other variable now, before where y used to be frequency, y is actually another data set. So this looks like sales. Okay, so these are sales in dollars and hundreds of dollars on the y-axis. So who can tell me what the scale of the x-axis is? What's the scale of the x-axis?
It's going by
Going by
twos, what it looks like.
Yeah, it's going by twos. Good. And then the y-axis?
by 100.
Yeah,
Oh,
it's moving by 100 each tick. I'm going to look and see if they give us any context. Each dot, so in the example shown here, each dot, so our observational unit corresponds to a particular day. So we're looking at a particular day. And so if I were to look at this point right here, this tells me that on this day, what was the temperature? Roughly in Celsius. On this day, the temperature was how much?
14 degrees.
Yeah, a little over 14 degrees, 14.1, who knows, but it's around 14 degrees. And then how much were our sales? How much money did we make in sales that day?
It's like a little bit above 200.
Yeah, a little bit above 200. Very good. So you could say, $210, who knows what, somewhere around there. But that one point corresponds to the same day. On another day, when we're out here, it looks like our temperature is around 23, close to 23, a little less than that. And we made about $450, or about halfway between the 400 and the 500. So what you notice about this is, first of all, the trend. As the temperature goes up, that means the temperature is moving to the right. As the temperature moves to the right, what happens to the dots? As we move to the right on this graph, where are the dots going? On the y-axis, are they going up or are they going down?
They're going up.
They're going up. So that means as the temperature goes up, the sales is also going up. Okay. So this is what's called a positive trend. I can spell right. Positive trend. As the temperature goes up, increases, the sales increase. So they work together. And if you notice, as the sales go down, or as the temperature goes down, meaning we go to the left, as we go to the left, the sales go down. So they're moving in the same direction. When you look right, just so you know, right in mathematics is a positive direction, left is a negative direction. So a positive trend. And I know it's not perfect, but what does this look like that you've seen of functions before in mathematics? What does this shape look like? It might not be perfect, but the general trend of it looks like, to me, what do you call that shape? What's the red shape?
I'm thinking like the slope.
A what?
The slope of slightly higher.
Did you say slope?
Yes.
Oh, what has a slope? It's a line. So even though these points don't exactly line up to a perfect line, the general formation kind of goes in what we call a linear shape. So for us, I'm only gonna worry about whether you know, is it linear or not? This shape is linear. It can be kind of molded into, it looks like it's going in the shape of a line. It's not curving. It's not, oscillating too much, going up, down, up, down, up, down. It's, you can fit a line to it. And all I need you guys to be able to do is tell me if a shape is linear or not. That's all I'm going to need from you. So let's kind of explore a little bit more down here. The last thing is strength, and we'll talk about that in a little bit, because it's easier to see strength when you're comparing two things. Okay. So as we move through this, I'm going to get rid of my drawings so they're not in the way. So sometimes there can be well, I'm going to get to the line y equal x in a moment, but so you guys take a look at that, but I want to jump to something else. So here we go. These are some different shapes, I think, that we can see in a data set. I'm actually thinking these are different trends. So notice this one on the left here. This is again, a linear shape. It's not perfect, but we can kind of see where the data is kind of forming the outside edges, the outside outline of it kind of looks like a line. Notice this one here. It looks linear right here, but then all of a sudden it explodes on the outside, or there's some points down here. So this is a weird shape here. It's not a very strong. So this is what we mean by strength. This over here on the left, that's a strong linear shape. Over here on the right, that is not a strong linear shape. Do you guys see how it's kind of like, it looks like it's linear and then it kind of goes all over the place. Okay. This one is, again, it can tend to look like a linear shape, but notice how there's a cluster down here. And again, it's not a very strong linear shape. What do you think the trend on this one is over here? What's the trend as you move to the right? As literacy rate goes up, what happens to total births? As you go from left to right, where do these points seem to be going? Up or down?
Down.
Yeah, so as you move to the right, as one goes up, they're moving down. So that's going to be what's called a negative trend. A negative trend. They move in the opposite way. So you'll see this as you move to the right, you're moving down. And then this right here is no linear shape at all. This is just everywhere. No linear shape to to this trend here. So the bottom right can be considered no shape. So all of these examples, these all have linear shapes, but very different strengths. This has a high strength, a very strong linear association. This one's weaker. This one's kind of weak. This one's a mess. There's no linear shape there. Here's what I mean by other types of shapes. Did you guys ever talk about parabolas in class if you have a quadratic? So this one, it's got a negative trend, and then it turns around and it has a positive trend. So that's a specific parabolic shape. But again, what you would say is just it's not linear. Okay, it's not linear because lines don't turn around. Okay, this one, if you see I fit a curve to it, it has an exponential shape, even though it could look linear, but it's kind of curving upward more. And if I fit a curve to it, it has an exponential shape as well. So again, all you need to know is it's not linear. So once we talk about the trend, or let's talk about the trend. These are both positive trends. Notice as you move to the right, the points are going up. Again, this one on the left is moving in a much stronger linear fashion than the one on the right. Okay. Notice now I want you to look at this R number right here. Notice how close that number is to the number 1 when you look like really close together. Not a lot of by the way, this is why we call this a scatter plot. This shape here does not have a lot of scatter. They're all close together. Okay, that's a very consistent, very strong linear shape. There's not a lot of scatter. Over here, you see a lot more scatter. And notice what's happening to this R here, 0.98. Now it's 0.48, and you're starting to see a lot more scatter. Now when R goes to 0.19, there's even more scatter. And when R is at 0, it's just a blob all over the place. Okay. This R here can also be negative, and you're starting to see a negative trend as we move to the right. The points are moving down. And then here, when R is -1, we've got a very strong negative trend. In fact, it's a perfectly negative linear trend. Okay, so R is going to mean something to us later on when we get to our unit R. But it's good to know that R is kind of speaking to the strength. When it's close to 1 or -1, we've got a very strong linear relationship. Okay, and here are again some other examples of R and the weak positive trend, the weak negative trend. Notice that R is in like no man's land here. And we'll talk more about that later. But what you need to know is that the closer that R is to 0, the weaker the linear relationship. Okay. So these are some descriptions of data. For example, in this one here, this is height and weight from a class. And when you're looking at this scatter plot over here on the right, what kind of trend do you see? Positive or negative? What kind of trend?
Would it be positive?
Yeah, as we move to the right, we tend to move up. So that is a positive trend. It's a linear shape, but it's not, super strong. It's moderately, but I would say moderately strong. There's a little bit of scatter in this shape. So this is an example of a poor description. And you want to be careful of these things. Most of the data is in the middle of the plot. What does that mean? Is the middle over here? Is the middle over here? You've got 2 variables. Since height and weight are compared, it tells us that taller people will weigh more. Well, that's not always true. because there are some taller people that don't weigh more over here. Like this person down here doesn't weigh as much as this person here, and that person's taller. So we want to use phrases like on average or tend to. So here's a good description. The variables compared are height and weight. And you guys all see that height is in inches and weight is in pounds. There is a moderately strong, positive, linear association. So notice they have strength, they have trend, and they have shape listed in this. Moderately strong, positive, linear association between them. This would indicate that on average, taller heights tend to correlate with heavier weights. See the difference in saying taller people will weigh more and just saying that on average, that's going to happen. And there do not appear to be any outliers or other extreme values. Okay. So, I mean, these are closest to being outliers up here, but they're not too far from the group. So you want to be able to say trend, and now let's talk about the line of y equals x. You want to be able to say trend, shape, and strength. And again, for us, shape is going to be either linear or not. Trend is going to be positive or negative, or if you have a blob, there's no trend, right? There could be no trend if you just have a blob of information. And then the strength. And the strength is probably the hardest one for us to get. So I'm going to jump over here to our height and arm span. And I'm going to make a scatter plot out of this data. Now, again, it's very important to note that our observational unit was a student, and each of the rows, this student who was 61.75 inches in height, they had an arm span of 62.5 inches. So each of these rows corresponds to the same person. So this 65.5 goes with the 63. This 67.75 goes with the 66. Do you guys see that? This is called paired data. So we've got paired data.